Okay, A is a 2-digit number. So A is a two-digit. So everybody has this questions, right? NMTC final round. This is this year. So A is 2-digit and B is 3-digit number. Okay. So what do we have? We have that A. What was it? A increased by B%. Am I correct? A increased by B% is equal to B decreased by A%, right? B decreased by A%. Is this equation correct? Yes or no? Is correct, right? Okay. And then we need to find A and B. Find all possible A and B. So A is equal A plus AB by 50 is equal to B. Okay. So yeah, so tell me, you people have tried. So tell me how to. This should not be difficult. Just an equation. Right? Any ideas? This will just come with some factorization, right? Minus 50, no. So 50 minus 50, right? Hey, so did anyone try? Aparna, Nagesh, Ishana already gave the exam, so I don't want to say if you should also try, but
But I couldn't try much because I was not well.
yeah, you were telling me. But then you see this question is easy, right?
Yes, sir. If you look at the equation itself, you can tell and pair that when A is 25 and B is 1.
But but there may be others. Can you say that from the equation?
And sir, just you have to derive.
Maybe yes and maybe no. Yeah, right. But then in the end, it is very simple. Ishana, do you agree that this is it, right? Now we can just we know what to do mostly. Yeah, it's fine.
Yes.
Yeah, but it seems very strange because how can it be 1? But then maybe that is because there is some calculation mistakes. But fine, you can take care of it, right? It is just factorization. Oh yeah, because it is 50A minus 1 or something. But yeah, it's simple factorization, so you know how to find this question. We'll skip this. Okay. So that's what I'm saying. The last questions looked very simple. So because I'm just glancing over them. So okay, now we'll try question number 7. So Ishana, did you do that one in the exam?
So the 8th question?
Mm-hmm.
No, sir.
Then what were you doing? Then why did you do it? Like, what was where did you get, like, kind of, where did you get stuck in it?
Sir, I couldn't factorize it properly, I think.
Okay, but this is standard factorization, no? We have done this, right? Anything like this, A, B, you have to just, no, this kind of things. if it is there, you can add something. You are allowed to add some constants, and so that it becomes factorizable, right? If it is something like this, for example, then if you add a 1, if there is 0 that side, you can to add or subtract constants so that it becomes factorizable. That is what I did, right? I didn't do anything else. I saw this factor, so I need to just write something here so that, yeah. Okay, no, so that is not, yeah, that you should have done, because we have also discussed this thing. But anyways, so what you did, no problem. Let's do question number 7. Okay, ठीक है, I'll give some more homework. I gave anyways. So BD is the bisector of angle ABC of this thing. Right. The circumcircles of BCD and ABD. Okay, so I'm just drawing the figure. Uh, so nothing is given. It's just a general geometry question. Not much is given. Yeah, angle bisectors. ABC. And okay, no, sorry. Yeah. Then what is it? BCD and ABD. Cut AB and BC. Yeah. So you make a circle through BCD and you see where it cuts AB. Yeah. Just a minute. Yeah. ENF. Yeah, you people just tell me the question. So, and then ABD, right? Circumcircle of ABD. Okay. So that we are cutting BC, right? No, this circle will not be like this. This will be more. Yeah. And this is cutting, this is F, right? Okay, what do we have to find? Tell. Uh,
So we
Sure.
need to 30.
A
Yes,
A equal to CF. Yeah.
yeah.
It is a general question, so it should be not much is given. Yeah, but it could be interesting. What happened? Oh, the meeting ended. Or what? Okay, no. Sorry. Anyways. So maybe you can focus on one of the circles at a time and try to do something. So on one of the circles, let's call this one gamma 1, gamma 2.
If E and F were the centers, then we could easily prove.
E and F, centers of what?
Of both the circles.
So you think E would be the center of gamma 2, like that.
Yes.
Mhm. So why would you be able to prove it in that case?
We can use congruency then. Because the common chord is perpendicular to the line joining the centers.
Okay. Right, so BD is the common chord, and this is the center of gamma 2, and this is center of gamma 1, and then it's perpendicular, which it is not in this picture, but okay, but then
That
why?
way BE is equal to BF.
But why?
So
Why?
because the two triangles
Mm-hmm.
are congruent.
Yeah, because of that thing. Okay. Yeah.
And BE is the radius. So if BE is equal to BF, then AE is equal to CF.
Yeah, but you see, that situation will not have never happen, right? Because I mean, it will only happen if the triangle is isosceles, right? Because uh, BE would then be BE would then be also equal to AE.
Yes.
Yeah, and then BF would be equal to FC. No, so I'm slightly wrong, but okay. Yeah. BF would be equal to FC, then these two would be the midpoints. Okay, no, so that can happen. Yeah, but midpoint, when is the midpoint perpendicular? Like that will never happen unless it is isosceles, right? So if you just take a triangle, you take the midpoints and you join it, right? Then the angle bisector is never going to be perpendicular, right? Because this is parallel, right? If the angle bisector is perpendicular, it means it is perpendicular to the bottom. It means that this is perpendicular, right? Right? And that means
Yes.
it's isosceles. So what you're saying will happen only in the isosceles case, and yeah, and in the isosceles case, uh, will it happen in all isosceles? I don't, but I think that is not going to be useful. I mean, yeah, I cannot say. Yeah, I don't think this is difficult. Power of points? Anyone? Anyone wants to calculate power of points? See, as I said, my first guess was to look at one circle at a time, because can you feel that this is not really, that these two circles are not really kind of connected in this question, in a sense that it happens for some reasons, which is sort of, so look at one circle at a time, right? Look at gamma 1. Okay, look at gamma 1, and now just forget gamma 2. Can you just do some power of point calculation? Maybe I don't need to erase. You guys already have seen these pictures many times. Focus on gamma 1 and do some power of point calculation. What power of point calculation will you do with respect to what point? Well, if you're looking at gamma 1, power of point calculation has to be with respect to A. Is there any other choice you have? No, right? B, E, D, C, they are on the circle only. You will not get anything. You do power of point calculation with respect to A. Okay, then you get it, right? And you should get it. AE times AB. I mean, I don't know, but I know that you will get it from here, I think. Like this is equal to AD times AC. All these things are known, right? ADAC you know very well, inside out, there's no problem. This is AB, this is it. This is AE, right? And then, as with what we were saying, right, the similar reasons, this will also be like that. What will this be? ADAC something, yeah, ADAC. Wait, what did we have to show? Sorry, it's here only. CB. Oh. No, I'm doing something incorrect. Yeah. This CDCA. Yeah, that is what is incorrect.
FB.
Right? Yeah. F. Yes, FFC. Yeah, FC. So CF, CB, which is fine, but then CDCA. Now you know, right, that these two things are equal. Right? Just check it. You don't even have to calculate anything, right? Cancel AC. You know that CD by CB equal to AD by AB. That is angle bisector theorem, right? Meaning that you know that it follows from something simple, and when you write it, you realize it is angle bisector theorem. Like you don't have to know see it from before. So yeah, AB by BC equal to. Is it done then?
Yes.
Yeah. So it is combining things we have seen. It is fine. If you cannot do it in the exam, well, that's fine. That just means that you have to write these exams more. Okay, you will perform bad in first few times. It's okay. It can happen. Yeah. So Ishana, how much were you able to do in this question?
Sir, I don't think I applied the angle bisector theorem. So I was stuck, I guess.
You did not apply, means you could not find a way to apply the angle bisector theorem.
Yes.
Right. So like I don't, obviously you will not remember, but like when I saw this from one perspective, my was like, can I calculate AE? Can I find AE in terms of that circle gamma 1? So I kind of forgot gamma 2 for a second, and I said, can I find AE in terms of gamma 1? And just can I find AE? And then to find AE, what will you do? Angle by this power of point, right? Isn't it correct, right? What else will you do to find AE?
Yes.
Yeah, there is no other thing that we know. So, and when you write angle by this power of point, similarly you do for that, then yeah, you are, I mean, angle bisector theorem comes automatically in the picture. So, yeah. So this is combining kind of things that we have done, but it's okay. I mean, this is what will happen first attempt, I think. But yeah, next time it will not happen. So you have to practice more of these questions. So let me just give you people some problems to try. I asked you, but I think earlier to try from there, but I think that method doesn't work. I have to tell you exactly, give you exactly the questions in writing. And next time we will discuss these questions. I'll not even ask you to remind me. I'll tell you. I'll ask you. Okay. Yeah. No problem. So this is going to be some factorization type problems which I want you to try. This is again the same kind of thing. So just okay. So note it down. Find all integer solutions. Okay. So find all integer solutions to. So this is x square plus 1 so x plus 1 plus 2 x minus y 1 minus xy 4 1 plus xy. Okay, this is one question. Maybe I think Aparna had tried these when I gave. I remember she was telling that yes, I tried a few questions. Okay. So, anyways, P and Q are primes. And in fact, I see that one more NMTC question is like this. So, yeah, that one they made A%, B%. They made it into a word problem. And another one is, I think they didn't make it into a word problem. Again, find all integer solutions. P and Q are fixed, okay? These are fixed primes. Okay. Find all integers x and y that satisfy this. Third one, I'll not give that, maybe it's a little more. Yeah, this one is in fact from INMO. Today was INMO, right? So Aparna's brother Raghav, okay, he used to take classes from me. So we used to, yeah, he wrote the INMO this time. Okay. So he sent me the paper, but I have not yet checked it. I have not yet seen the paper, checked it out. So find all integer pairs. I'm not sending it to you people now. You should try it if you can find it. But I'll send it to you maybe next week or something. Just because first you try these homework questions. Last one, okay? X squared times y minus 1. This is also same integer solutions. You will see that the method is similar in all this, but obviously there are twists. Yeah. Plus y squared times x minus 1. Okay, I'm not telling the source now. I will tell you that time because the solutions are given in that. So I could have given you from the exercises in this chapter, but anyways. Okay. It is from the T2's book. So T2 Andrescu's book. Yeah, let's move on. Note it down. Then we move to the next question. So you see the last question, few questions are not difficult at all, right? Compared to the first few. First few you got stuck maybe. So yeah, you can note it down in your copy. Okay, don't take pictures and so on. Yeah, if you write it, then you can do it next time. These days, people want to just take pictures. So maybe that's more optimum, but okay. So should I think you guys write faster than me. Should I now move to the next question?
So
Yeah, okay. So I'll move to the next question. Means the previous question. So just tell me the question. Anyone? Aparna, you have the question. Just you can say the question. Just the previous one, diaphragm, because I don't have my phone with me. I have to change the tab.
yes, sir. Mn are integers such that n square times m square plus 1
N square times m square plus 1.
plus m square times n square plus 16
Hmm?
is equal to 448.
Hmm?
Find all possible ordered pairs m, n.
Right. bumper. It's a lottery. People who are good in Diophantine equations, it's a lottery for them. Yeah, but I don't know if we can do it. Let's try. Yeah, tell me, what have you people done for this?
Sir, I could find all the pairs, but I had to do a little bit of trial and error.
Okay, so you can tell in some kind of summary, if you just say it, right? Whatever you have done.
So I tried to take the minimum value possible for m. So that is 1, as it's an
Okay.
integer.
Hmm.
So the minimum value of m will be the maximum value for n.
Right.
So I got one solution already as m is 1 and n is 12.
Okay.
And then I just had to try for values less than 12 for n.
Right. So did you write that when n is minimum, n is equal to 1, and then 12 is the largest possible solution,
Yes, I wrote that.
right? Just by size considerations, right? That
Yes.
nothing more than 12 can work. So that is it. This is a silly, simple question. Yeah, that is okay, right? Because either way, there's some of this is square, this is square. So how, I mean, even if you take anything bigger than 2, yeah, you understand, right? It will not work. Yeah, 12 if you take, yeah. Yes, so you say that this is the function and this is 2 variables, right? And the largest, and this is equal to a constant, and when m increases, the quantity increases. When n increases, the quantity increases, right? So yeah, it is fine. I think you can just say, right? Yeah, you can just say that when n is smallest, then the largest value of m is that is it. I don't think no much to do. But we can obviously try to factorize it also. Anyone has tried to factorize it? Let's try that. M square plus n square. Like as I was saying, right? Like you can add, subtract numbers. You're allowed to do that. This kind of problem, right? Yeah, there is a 2 now, which you cannot really, you can bring it into the picture. Yeah, so I can write right? I can write this. I can take half common, or maybe I'll write 16 here only, right? Whatever. And this becomes 8, right? And then you can factorize. You're done, right? Just factorize it. These things can always be factored. We have discussed this factorization before. Do you people agree or not? We have discussed this kind of factorization before, right? That you squeeze in a term and this thing you factorize it, right? So, and of course you can then multiply by 2 and make it integer, and then actually it becomes much simpler to say, right? Even if the number is bigger, you know that it's, yeah, that way it is maybe faster, right? So you see this question, last question, it's a bad question paper, I would say. Last 2 questions are of the same kind. So anyways, is the method okay with everyone? I'm not really doing anything. I'm just repeating the same thing I did in the last question, mostly, right? This thing is just like this constant c that I'm adding. It's not a miracle. Is it a miracle? No, right? It is nothing. It is just that, okay, I need to add some c. Let's find the c. Let me see if I don't think. Then also can I do it or not? You can do it, right? So you have this n square plus c, and then what does that mean? It means you want 2n square. So obviously 2n square means that you do this, and yeah, then maybe you can say I will do this, and then you take half common, and then you can find the c. You know the 2c should be 16, so c should be 8. So you can find it. It is completely findable, right? Means computable algebraically. So these are the questions which we are doing. So we have done 3 questions today. Okay. Is the 5th question easy? Given 69 distinct, yeah, let's do it. Given, yeah. So what is it? Just tell me. Given 69 distinct.
Positive integers not exceeding 100.
Less than equal. Okay. Then
Prove that one can choose 4 of them, A, B, C, D, such that A is less than B is less than C,
strictly
and
less than.
A is less than B is less than C.
There's no equal to. Okay. Okay.
C is not less than D, that's not given.
Oh, sorry. One can choose A is less than B less than C. Okay.
And A plus B plus C is equal to D.
Then what is
And
D?
is this statement, D is any number taken from 69 distinct positive integers?
Okay.
And is this statement true for 68 also?
Okay, that's a separate thing. Yeah. Given any 69, basically they're saying given any 69 numbers, you can choose 4 numbers, right? One can choose 4 numbers A, B, C, D, so that the one of them is the sum of the other 3. Right. That's all, right? This is the
Yes.
condition. Is nothing. One of them is the sum of the other 3.
We
So
can
that
take the maximum range, right? 32 to 100.
you don't get to decide the range, right? You have to say that for any 69 digit, any 69 numbers, you can do this.
So, but if we prove for the maximum, then we can show it for the others also, right?
Okay,
Less
I
than
don't
1.
know. I don't know that. I don't know that. So okay, so uh, for the maximum 69, let's
Like
see. Mhm.
for 32 to 100, if we can prove it, then we can prove it for the others also. Like 1 to
Maybe,
69.
maybe. So how do you prove it for this thing?
We have to prove that we can choose any 3s, any 4. So we can just choose the first 3.
First 3
32,
and the
33,
fourth one.
34.
Fourth one is the sum, right? Yeah. But the problem is
Yes.
that if you, so this is fine, but then how do you prove it for any 69? Right?
Because this is the maximum sum, right? The
But
sums before this will be less than 100.
but the set will also be more complicated. It won't necessarily be consecutive integers. Right?
But we can choose one trio out of them still.
How? You can choose 3 out of them, but why will the sum be in the set? Is that obvious? No, right? So you are using the structure of the set also, right? That there is 32, 33, 34, and there is 99. But in some random 69 digits, say some 69 distinct numbers, that sum may not be there. It will be there, we have to show that, but it is not obvious, right? So Ishana, do you see that that is incomplete argument a little bit? Or is it?
Sir, even if we say the maximum value from the range is like 90, then also the numbers we can choose, like they will be, since they are 69, they will be less than 20 or 30. So we can add them always.
Yes, but then why will the sum be there in it? That is the thing, right? The sum D also has to be there in those 69 numbers. You see, right? Like,
Yes.
yeah, that's the thing. Like you take 30, 32, 33, 39, 34, but then instead of 99, I'll remove 99 from this set and put 1. Then 32, 33, 34 does not work. Right. Then I have to take something else. So it can be
Yes.
complicated, and you cannot actually tell which 3 will work. That you have to prove existentially. You have to show there are some 3. You cannot actually find them, I think. Exactly. Less than 1 minute is left, so we'll do this on Google Meet. We know the question now. Let's think how to do this. There's some pigeonhole principle, maybe, I think, come into the picture.